Okay, I said AI exists for predicting the future. So let's try to do that. Here I prepared two columns of data. One is this is sales status of lemonade, orangeade. So I get rid of other aid, just left lemonade. So here's the temperature, and here's the quantity of sales. So temperature 0, I sold 4 lemonade, and temperature 1, I sold 4 lemonade, and I sorted the status as for your convenience by the temperature. So here you can see the whole data set is only 32 rows. And can you guess if I say that, okay, how much can I sell on temperature 36 degree? Then you can say that 99 or 100. How? Because you have a instinct, but the machine doesn't have any instinct. So there our algorithm begins. So the first one is just guessing by the average value of these numbers, this sales number. Okay, I want to show the chart here. So here's the temperature, here's the sales quantity. And yes, you can guess, you can draw a line like this. And you can say that the y equal 2x plus something. Actually, this will be the minus something. So you can make a formula from this data. But machine cannot do that. So their way I will explain by this Google Sheets. The baseline is estimating by the average value. So I calculated here the average value of this sales value. Oh, I got wrong. It should be 2. Yes. Okay. So I put that. What's wrong? Okay. Yes. Okay. So I put that everything here, and I copied all the formula here also. So everything same. So I just estimate the temperature with 34. Temperature 1, 34. Temperature 35 with 34. I guess like that. That's very dumb guessing. By this, we can calculate the error. Error means the estimation and the real value. So I got the error by this formula. Yes. The estimation minus the real value. That's the error. In statistics, we say that this is, I forgot the term, sorry. And we can summarize all these things, and we will get 0 because that's the average definition, the definition of average. So it's better to get absolute value of this and add, or we can get a squared value of this error and sum. So let's try squared value. Multiply the same value. So we got this value, and of course, yes, fill it up. Let's reduce the digits. So we got this value, and this time we got sum of this value. So I calculated the sum of those things here is same with the sum, and I want square root of, okay, I calculate the average value of this one. So all this value, I calculate the average value. And I want square root of this value. So this is the error, and this is the average of error. And it's squared. So if you root, that means it's the average error. So we got this value. This will be our metric. Metric means the indicator. So now it's time to you do your exercise. Make a formula like where I will make this value temperature multiply 2 plus some value 10. Actually, we already knew that should be minus. So I make this one and I put whole to there, and we got the error. So this value minus this value, that's error. And we can get square value also, and so on. Oops, what's wrong? Okay, that's the matter. I have to put here. Not that one. Okay. Delete and make it again with this one. Okay. Yes. So I put the same calculation formula here with exactly matching with this one. So I calculate the whole average of this error and whole sum of this error, and I put the squared value of that one also. So I will reduce the digits, and here you got that. So you can make the formula better, and here's the average of error. That was when we do this one, that was 763, and this time is 183. So it's better than this one. Yes, we did good job. The mission is to reduce this value as much as possible. So if this value goes 0, that means you guess perfectly. For example, if I copy this value and put here by pressing Shift Ctrl V, then yes, error, there's nothing. So all error goes 0. So average error goes 0. So you got a perfect guessing. I pressed Ctrl G, undo. So let's do that more easily. This is, we call this as intercept in mathematics, but we call that bias in statistics. So I will put that here, the bias, and I will change that by Q2, this number, and I will add absolute coordinate, and I will copy that also. And I will put this one with a slope in mathematics, but with a weight in statistics, same thing. So I put that here, and I will change this value to P2, and I will add absolute coordinate. So copy it. Okay. So we got, did I do wrong? Yes, that's right. So we got error 226, it was 18 something, right? Let me do that back. Yes, minus 10, okay. Oh, I see. That was why. Redo, and it should be plus. Yes, I added here minus, that's why. Okay, plus. And copy the formula to the far end. Yes. Okay, so we got the error 183. And this is better than this one. And we can, as a machine, we can change this value a little bit. So here we use running rate, and I'll say that it's just 0.1. Okay, as a machine, you can choose this value randomly at first time. Yes, just random. So let me do that by choose 5, and we got error 2000. It's worse than this one. And I will put that running rate. How about 2? No. Okay, 2. So I change this number by 2. Adding 2, then it should be 87. And that was 2060. 2677. And when I changed to 7, wow, 8000. That's worse. So it was 5, and when I moved to 7, it's worse. So I will go backward. Minus 2. 5 minus 2. Then it's 3. So when I put 3, oh, that's better. Even better than we put 2 here. But machine doesn't know that yet. So we got this number. And again, minus 2 again. So this is running rate. So we can change this value by this running rate. So with 3 minus 2, that means 1. So I change this number 1. Ooh, that's worse than 2. So let's go back, undo. Okay, this is the best value that we got. So let's fix it, the weight here. And now let's change this value to with this running rate. So plus 2 means minus 8. It was 163, 203, worse. So let's go back 10 and add 2, means minus 12. Oh, it's better than that. So minus 14, better than that. Minus 16, okay, good. Minus 18, yes, do that continuously until you find the best value. So machine can find the best value for this number by doing this one continuously, repeatedly. Human, they are very boring doing this, but machine does not bore that. So I will do just twice more. And yes, it's already okay. 83 goes to 82. 2 minus 2. No. 82 change to 90. So the best value we found is this one. So that's the best. But how about when you change this number to just 1, then you can find more best value. But finding the best answer, you will get long time. How about this one? 0.1. You'll find really best answer, but the time consuming is worse. So if you set the running rate large, then you cannot get the correct optimal value. If you set the running rate too low, then it will get long time to get the optimal value. So this is how machine learning find the best value for our formula, this formula. So machine learning use this formula everywhere. Very simple formula. And at first time they set this number randomly and change this number with this running rate and find the best number to reduce the minimum error. That's it. That's how you can find the best value for that. So by this formula, we can estimate, well, in temperature 0, we estimate minus 20. Okay, it's better to not going to cell. Just stay home and enjoy your vacation. That's better. And here we can sell, see, almost similar. Yes, how about this one? Almost similar. Here, almost similar. So in this area, we got wrong number, but it's okay. To get better result, you can separate those values and do some other ways, but this is 101, just beginning class. Let's do it. And there's something else in sailing. So sometimes temperature affects the sales, but also there are some leaflets and price also affect the oops that's temp yes okay that's date, and this is quantity of sales. So sometimes the other things also affect this number. So in this case we make y sales equal W1 x means temperature plus W2, that's the weight, and replace, and plus W3 price. And how about date? Well, yes, you can do that, but let's skip that. And intercept means bias. That would be our formula. So you have to find those values, W1, W2, W3. But machine can do that. That's how machine learning runs the regression. Oh, I forgot to explain what is regression. So in AI, we usually guess the number, then we call it regression. It's from mathematics statistics. Y는 y equal x, w1 x, wx plus b, and guessing, finding the value w and b, that's the regression. Sometimes we do not guess the number, but we just guess fail or success, or cancer or not, die or survive. That's a survive. Those things we guess, that we call it classification. Classification is what you can do after understand this regression.